AI is an amplifier. It allows you to move faster. And anytime you take a task and you compress it, it puts pressure on all the others.
Yeah.
So if you have really slow CI, well, guess what? That's going to be a big problem. So you need fast CI. If you don't have test cases, that's going to be a big problem. And but fast CI, test cases, like these are all actually best practice anyways.
Yes.
And so again, what AI is doing is just forcing a conversation. Everybody is now a manager. You have to think about things with manager thinking. Even if you're super proud of never being a manager or something, well, you have to bring and learn the thinking. Even if you're fresh out of school, and again, I think some of these folks learn way faster than others, you have to bring that thinking because it's not just about the outcome, but it's about what am I trying to achieve? What's the best way to do it? What's it going to be like to maintain this over time? Right?
Hey, Luca here. Welcome to a new episode of the Refactoring Podcast, where every 2 weeks we interview a world-class tech leader. Today's guest is Chris Lattner, one of the most important engineers for modern computing. Chris invented key compiler infrastructure tech like LLVM and MLIR, but he's also the inventor of the Swift language, a key contributor in bringing Google TPUs to market, and a lot more. Today, he's the founder and CEO of Modular, where he's reinventing AI infrastructure to make software portable across GPUs and platforms. So with Chris, we talked about his vision for AI and computing. We talked about how Modular's mission makes us closer to a future where AI is open and portable. And we talked about open source, how AI is both empowering and straining contributors, how it's changing intellectual property, and what workflows we need to change as engineers. And finally, we discussed how AI is changing software craftsmanship, how he's bullish about junior engineers, and a lot more. This was truly an incredible chat, so let's dive in. Welcome, Chris, and thank you so much for being here with us today.
Hey, Luca, I'm very excited to be here, so thank you for having me.
So, Chris, you really need no introduction, but I'll try anyway. These days, you're founder and CEO of Modular, where you build AI infrastructure to make software portable across platforms and GPUs. And that builds on your lifetime experience with the compiler infrastructure projects you created like LLVM, MLIR, but you also created the Swift language, you brought to market Google TPUs and contributed to many, many projects over your time at companies like Apple, Tesla, Google, and more. And you're also, and that does not escape me, a pretty damn fine woodworker. Would you agree with that?
I try. I don't know if I'm, particularly elite, but I do make some furniture and some tree houses and a variety of other things. So I like to build things.
Yeah, while I was prepping for this chat, I saw the pictures on your website in complete awe of the things you built, like the tree house, the dining table. And so I think I know what's going on here. I think woodworking is like your hedge against this AI future in which only the practical skills survive. Am I right?
Well, so I think that what you can read into that is that I enjoy building things and I enjoy discovery. I like to be proud of the things that I build. I don't think that's completely unusual, but maybe I'm a little bit more, willing to throw myself into it and make a few mistakes along the way.
Yeah, love it. So jokes aside, I'd love to talk about your work at Modular, which, as the name suggests, it is made of many pieces, many interconnected parts, like the Max framework, Mojo, Mammoth, and a lot more. So first of all, how do you even define what Modular is? What's your elevator pitch as a founder, raising money left and right?
Sure. Well, so first of all, let's take a step back and look at where we are in the world, right?
Yeah.
You may have noticed that AI is happening, right?
Yes.
Everybody's trying to figure all this stuff out. People are buying billions of dollars of GPUs and putting them in gigantic data centers, and everybody's in a race to build into and explore all this technology, right?
Yeah.
Meanwhile, it turns out that it's really hard. There's a lot of technologies that exist that were built over the last 10, 20 years. They sort of kind of work, but it's all duct tape and baling wire. And so what's ending up happening is that we have this huge gap between what can be achieved by the most elite teams, the biggest companies, or with the most well-funded research labs, and then what kind of everybody else can do. And so you see this great consolidation, like, everybody's running on like the OpenAI endpoint or something like this, but it doesn't square with like AI is not new. Everybody coming out of a computer science program has been taught AI for the last 5-10 years. But we can't actually map that, right? And so what Modular is trying to do is it's trying to crack this open. The root cause of this is a consolidation in the industry with many powerful forces all coming together, but then also a lack of modern technology. And so our hypothesis, our approach is to say, look, let's bring the best in class compilers and languages and ML frameworks and this technology, cloud serving. Let's bring this all together in a best in class way that was actually designed for the current world, rather than trying to take something that's 10 years old, which by the way is ancient in AI terms, or 20 years old, like CUDA, which is just like completely a dinosaur. Instead of like taking these technologies and trying to get them to work, let's actually build something designed for the modern era. Now, the modular approach then is say like, okay, let's go do this fundamental research. Let's go make big investments. Let's really crack this open. And that's what brings us to the outcome, which is things like Max and Mojo, which I'm really happy to talk about.
Hey, if you're using AI to code, you know the pain. Too many terminal panes, multiple agents running at once, copy-pasting context between them, and trying to remember which branch has what. So the bottleneck is not writing code anymore, it's coordinating the agents. And I've been trying a new app these days from Augment Code called Intent, purpose-built to solve this problem. Intent is a developer workspace built for orchestrating agents, not just running them side by side. It starts with the living spec that updates as agents make progress, so every task stays aligned with no manual coordination. Intent works best with Augment's Oggy and their context engine, but you can also bring Cloud Code, Codex, or OpenCode. Intent is what comes after your IDE. Try it for yourself at augmentcode.com/intent. Yeah. So what do you think was subpar in the solutions that we had before? Was about performance, like interoperability? What is the gap that you've seen exactly?
Yeah. Well, so there's a couple of different ways you can look at it depending on what part of the problem you're studying. So if you look at software today, look at software engineers today, vastly all of them, like, I don't know, 99%, probably 98%, are all programming CPUs. Right. And so people are fighting over, is Rust going to be better than something else? Well, Rust is a CPU thing. It's 15 years old. It's cool, but that's not actually what's going on right now. What's going on right now is AI and GPUs and accelerators and new chips, and like this is a huge explosion of compute, and people are vastly all focused on the wrong thing, in my opinion. Now, CPUs are important and CPU software is well understood. I get it, but what I want is I want to crack that open, like get those people so they have access to this new technology. Modern computers are massively accelerated already, and the CPU is a tiny part of that. So that's one half of this. So it's accessibility, democratizing it for people that otherwise wouldn't even touch this stuff because it's scary and complicated. The other side of it is the people doing GPUs. There are these battle-hardened veterans that can actually, they're super awesome, super smart, amazing people. They don't really want new technologies because they're experts in the old stuff. And so they're the wizards that then get pulled out of the closet to go solve these crazy problems. And they can be effective, and amazing things are happening. Like, look at what AI is doing all around us. But the problem is there's so few of them. We're being held back. And the technologies they're using, again, they can work if you hold them the right way. But it's actually so difficult to do that, so expensive and slow, that even the biggest labs are having big problems. And finally, what's ending up happening, the biggest problem of all, is that there's so many new chips coming from startups and hyperscalers and things like this, and there's no consistent software platform that can scale across all of them. And so what we're doing is we're saying, again, build a modern software platform that can scale, that can be usable so that even Python programmers can get into GPU programming. It can scale across different chips. So yes, it can work on NVIDIA, which is really important because NVIDIA is an amazing platform and there's so many amazing GPUs out there, but also on AMD and Apple, and we have upcoming new ASICs and specialized accelerators that will be launching this year. And when you do this, like what we really want to do is we want to pull forward innovation. We want to pull forward the community. We want to pull pull more people into this modern world so that we can get more innovation and more cool things happening, not just from the biggest guys, but every tiny research group that has 5 people in it should be able to do this.
Yeah. So I'm thinking back at what you said before, that one problem is that there are generally few people who can work on this today. And I'm wondering if the problem you think it is, I mean, on one end, it's probably that it's generally some kind of more new stuff that is growing today, but maybe it's also because, as you said, tools and infrastructure is still less mature than what we have had with CPUs for a long time, and so we work at the level of abstraction that is maybe too low. It's too hard versus how hard she should be. Am I right?
Well, let me give you an analogy. So years ago, I was at Apple, and Objective-C had made the iPhone possible, right? It was this amazingly powerful technology. It was efficient when you needed it, but it was also high level for frameworks. But it was also built on C, and it was also decades old, and it was also pointers and square brackets and scary, and it was actually really difficult to use. But if you were an expert, it was very powerful, right? And so I built and brought Swift into the world, and one of the things that people saw is that, okay, well, it's prettier, it has modern features, like it's a cool thing. I'm very happy and proud of Swift, right? But what practically happened is it massively multiplied the number of people that could build iPhone apps. And so it was very funny because some of the Objective-C people were very kind of grumpy about this. Well, I'm an expert already. I don't see the problem, right? But what was happening is Objective-C was gatekeeping app development and preventing people from getting into the ecosystem. And so today you have exactly the same thing happening. You have CUDA, which is venerable and very important, but it's also based on C++, which is 40 years old. CUDA itself is 20 years old. Like, it wasn't designed for modern GPUs at all, right? And so it's possible to use it. And if you're an expert, cool, you can be effective. But I look at all the people that should be using it, and there's 10 times, 100 times more people out there that should be programming GPUs that are. I think that as we crack that open, it's just a huge opportunity for the world. It's a huge opportunity for programmers to upskill. There's a lot of great things that you can do with this.
Yeah, I think the analogy between Swift and Objective-C is perfect. And it also speaks to me because I was a startup founder by the time, Swift came out. And I remember we were working on our mobile app in Objective-C, and we were coming from Ruby on Rails. And I remember thinking, wow, Objective-C is really something when it comes to, the different altitude that you have to work with compared to a web app. So I can totally see that. And I think if we keep the analogy for your work on GPUs now, one value proposition is that we are going to raise the level of abstraction without paying any penalty in terms of performance, in terms of how the thing works, just like Swift and Objective-C are compatible in a way with the underlying infrastructure.
Yeah, and so if you dive into Mojo and say, well, what are we doing about it? So there's a big problem out there. There's a big opportunity, in my opinion. What we did is we said, okay, let's go build a new programming language.
Yeah.
But so in the case of Swift had to go solve a syntax problem. Objective-C syntax was kind of a big part of the problem. And so build a modern language with new syntax. Today, we don't have that problem. Today, we have good syntax, Python. But what we have a problem with is we have missing compilers. We don't have a good way to be able to target heterogeneous accelerated compute from different vendors, right? And so what we did was we said, okay, let's go and build a fancy new compiler stack. We use the MLIR compiler framework that I built a few years ago for accelerators. Let's build a completely novel pipeline that allows very powerful metaprogramming, full control over the hardware. You can go all the way down to assembly if you need to, but you can actually build much more powerful high-level abstractions. And as you say, abstractions give you power because you can reason about things more declaratively and at a higher level and get away from the details. But we also need to be able to expose all the wacky AI stuff. And so there's these 4-bit floating point formats that are super, super fancy and very important, right? And let's lean into this and prove that we can build a stack that can be, as fast or better performance than CUDA on NVIDIA, but also portable. And unlike any of these things, also run on CPUs.
Yeah.
And so one of the really cool things about Mojo is you can go pip install it. It's free, by the way. Just go nuts. You can pip install it, and then you can run on CPU. And so you can say, hey, Claude C compiler or Claude, go please migrate my Python code over to Mojo. And often what you'll find is it will grind away and burn some tokens, and then you'll get something that runs 700 times faster.
Yeah. Yeah.
And the resulting code is Pythonic. You can read it. It actually still looks reasonable. It's not like it switched to a completely different universe. And when you do this, suddenly you say, okay, well, that's cool. How about we get on a GPU? Now you can get another 1,000 times faster. And then, you can keep taking these steps. And what you can do is you can learn each step along the way.
Yeah, it's amazing. I mean, I remember while I was doing some research for this interview and got more into modular, what struck me was the scale of this work. And the fact that it seems to me, and then you'll tell me if it feels that way to you too, that it builds on everything you have deeply cared about in your career, like open source, interoperability, compilers, programming languages. It's all in there. And basically, I mean, I think some of the best founder stories, you look at them backwards and it seems like the founder was destined to do that, right? Because you can connect the dot backwards and it feels like everything you've done in life has led to that. Does it feel like that to you?
Yeah, absolutely. I mean, the way I explain it is that modular is kind of my life's work. Right? This is not something that woke up one Thursday and decided, let's go build a startup and see what happens. It's been very carefully planned. A lot of the work has been done across the course of many years. A lot of the work was learning. And so part of the learning that went into this was building and scaling the Google TPU software stack. Right? And so for years, I was working on TensorFlow and TPUs and XLA and JAX and all building compilers and runtimes and understanding the scope of the problem. And without that experience, I could never have done this because, you need to see things at scale. You need to be able to work with the researchers that are pushing the boundaries. You need to understand what they really care about instead of just like building an abstract thing that you hope is useful.
Yeah, absolutely. And I mean, hearing you say with your story, hearing you say, this is my life's work, it's really something, right? So it's really fantastic work. And look,
I'll admit, like, I actually love what I do, right? So this is that is also part of the secret, right? And so I'm very happy that it's valuable and it's solving real problems for very, very important people.
So in speaking about the fact you love what you do, for someone like you who has seen like everything in engineering, what makes you the most excited about your work right now? That is, what is the challenge that gets you up in the morning and you're excited to solve about this?
So I'm a very strange person because you talk about woodworking. I love building all the things, right? And so I love whether it be last night working on a compiler thing and the Mojo compiler, fixing the variadics representation. It's like this tiny obscure thing that nobody should have to care about, but when it clicks and it gets right, you know that it's right. Now you can continue to build the world on top of it, and just like that happiness from one small thing that is right. It gives me a lot of pleasure.
You tell me you're still coding as a CEO of a billion-dollar company.
You can look at my GitHub. I probably have a few thousand contributions this year. So yes, I'm actively helping the team. I'm not a lead programmer or anything, but I'm a good hobbyist. But I also love building teams. So building and getting amazing people together, inspiring them, giving them ways that they can actually grow in their careers, and actually they can contribute and they can do really cool things and they can point to it too, and they can take great pride in making the world a better place. I love the business side and working with customers, and when they're so excited because they can get better performance or latency, or they get we have people that love our stuff because they just can move faster, right? Or they like it because they're trying to hire new people, and it's really difficult to get people that can work on these legacy technologies, right? But it's very easy to learn the modular tech and upskill and grow, and this is fantastic for people that want more AI in their products, and that's amazing. And it makes me so happy. I do like talking to people about this and educating them. And so some of the blog posts, when I get a chance to write, I enjoy that piece as well. There's a ton of different aspects of my work. And so I love all the different pieces in different ways.
Yeah, love that. So I wanted to ask you also about the vision, because I think AI companies are about the future, right? And it feels like, especially the best ones, they're bringing some kind of point of view and something that they stand for. And it feels to me like, looking at your work, the modular, that things you stand for are portable infrastructure, open source, interoperability, and so on. And we know the AI stack is made of many parts, and some of them are more vertically integrated right now, the frontier. Others, we have open source that is lagging behind, sometimes slightly, sometimes more. So do you think you have a vision of the future in which AI is eventually more like a commodity, more like electricity, like some people say, which is open source top to bottom, or it's always going to be a race against frontier lab and centralization and so on? What do you think?
Well, so I agree with you completely. So I do have several strong points of view, and if you push me on them, I'm very happy to share them.
Yeah, absolutely. I'm here for it.
Yeah. So my view is that AI, again, we get out of the bottleneck we have right now, where all the systems and processes and things like this force a consolidation on a few pretty legit, amazing teams building the most, world-leading models, and then everybody tries to like build on top of those and follows their lead. Yeah. What should happen when we solve that, when we crack that, is the AI becomes just another programming paradigm. That's all it is. It's a great way to solve a class of problems in software. And usually those problems are at the boundary between human perception and human interaction and the real physical world and computers. And AI is the thing that really changes the narrative, because before AI, you always had to work with the computer. Like, you had to figure out how to type on a QWERTY keyboard, of all things. Like, what the heck? Like, that's not a human thing. That's a forced computer thing that we're having to meet the computer. But now AI is allowing the computer to meet us and work with us in the modalities and the world that we live in naturally, right? And so that's fantastic. And when you look at a lot of the reasoning capabilities, like, this allows us to build into new kinds of capabilities that we otherwise couldn't do. But at the same time, you still have traditional software. For loops are still a thing. Like, they're definitely not going away. And so replacing all software with just an AI model doesn't really make sense for any economic or efficiency or latency or whatever reasons, right? And so I'm a huge believer in AI, but I also want people to be a little bit more balanced than the hyperbolic, like, we should just replace all software with end-to-end models, which doesn't make any sense to me. So, but when you look at that and you say, what is AI as a programming paradigm? It can be something like object-oriented programming back in the day, or structured programming when, people figured out the go-tos were a bad idea. What they can do is they can open up more complicated, higher abstraction problems that then allow software to grow and solve bigger problems and have bigger impact. And that's really what I want. And yes, LLM chatbots are a cool thing, and agentic things, like, all that stuff is super cool, and that definitely should not go away. But I'd be way more excited to see, your next watch app having an innovative model that does some triangulation on real world data that, only it can detect, and triangulate it with, I don't know, something in your bike tracker or something, right?
Yeah, absolutely. And speaking of AI and programming paradigms, as you've said, one topic that I wanted to discuss with you is about open source, because of course you've done a massive amount of open source work in your life, and AI is changing a lot how people and maintainers are thinking about open source. And I know you've written recently about the Claude C compiler, and there are many instances of other projects being like rewritten or created with AI. And there are so many angles to discuss about this. But first of all, at a glance, are you more excited by what AI makes it possible for open source, or are you more worried?
I'm a little bit worried, honestly. Right. And so I think that I'm worried about it for a couple of different reasons. Again, I'm very pro AI, and so I'm very excited about the tools and capabilities. But what it means for open source, I think, is a really big open question. Yeah. And so I've seen, among other things, I'm on the board of directors for the LLVM Foundation, right, that oversees the LLVM community and things like this. I'm involved with many other different open source projects in different ways. Open source is very important to me. Modular is open sourcing like tons of stuff. Like, come please join our community. It's super important. And I think that what's happening is that AI slop is really overrunning a lot of the maintainers. And the trade-off with a well-run open source project has always been that you have maintainers that are long-term community members that are responsible for certain areas. They're growing their responsibility in their career. They're investing in the project. And as you have new contributors coming in, the maintainers want to invest in those people so that they can grow into being contributors and an important part of the project someday. And for a project like LLVM and many others, this dynamic has always been a very healthy co-investment, like between long-term maintainers and new people coming in. But with AI tools, what's happening is that a lot of maintainers are getting overrun. They're just like, all this people are slop coding things. And because the contributor doesn't have to do nearly as much work, but the reviewer has to do the same, but at a bigger scale, like what's happening is that I think it's going to lead to new contributors not getting the attention that they deserve. And I think that could have a long-term bad impact on the health and vibrancy of communities if you cut off that inflow of new contributors coming into projects. Now, it could be that we just need better tools. Some people think that, okay, well, someday in the next future model that will come out, the models will actually be perfect and all the contributions just work. And if that's the case, then I'd say, okay, well, do you need open source anymore if you can just theoretically vibe code entire kernels from scratch? I mean, if you think that's a good outcome, then that also isn't really great for open source projects and open source communities either. And I'm personally very skeptical of that. So.
Yeah, I'm skeptical too for what matters. I mean, just like before you said, for as good as AI can be, it's not like we're going to replace old software with AI because it doesn't make sense for inefficiency, performance, latency, and da. At the same time, I think that composability and using stuff that we've already done, it's something that I find a hard time thinking that it's gonna go away because we can just recreate stuff from scratch. I mean, if we were able to, right? It would feel like completely inefficient and would feel weird that we haven't found a better way to just reuse stuff.
That's right. Well, so and it doesn't even honestly make sense. AI can generate large-scale software. Well, that's proven. So I wrote a blog post I know you've seen talking about the Claude C compiler. And it's very impressive what a team of agents with effectively zero human input can go and make a C compiler that it's not production quality, but it's interesting. Like I find it very interesting, let's just say. But there's no novelty to it. And the reason it worked is because it has a huge amount of C compilers in its training set. And so it's basically transcoding LLVM and GCC compilers that exist into a new form. Well, so that's cool, but that's not cool for creating new things or driving the world forward or building consolidated communities of people working together. That I think is going to be most useful for people that want to like strip licenses. And so you say, okay, well, I don't like the GPL license. Hey, Claude, go rewrite this from C into Rust. Now it's not the same thing. I have questions
about that too in my notes.
So, or here's a proprietary program. There's been a problem in the LLVM community where somebody took some proprietary EDA tools and then used agents to basically clone the behavior. It actually disassembled the tools and reverse engineered them, which is against the license, by the way, to generate an outcome that then cloned a lot of the behavior of this proprietary tool. And so I don't think it's just open source that's got to figure this out. I think all software has to figure this out, but I do think it means we should change how we think about the value of the software that we're creating and the people that maintain it and the communities that drive it. And I think that's actually the key thing that a lot of folks aren't even talking about.
Yeah, I mean, this is so interesting. I have like 1,000 questions about this topic. So about maintainers and open source authors being overrun by this, I mean, there are many prominent people that are coming out saying this, from Mitchell Hashimoto to TL Draw, actually closing external contributions. And as Mitchell said, like throwing the baby with the bathwater while doing this. Do you think this is a matter of figuring out a better workflow? Because maybe, the way we've been working so far with PRs and stuff, it was optimized for humans and had some implicit assumptions about humans that just don't stand anymore, but we will settle on something that works. Or you think we are kind of in trouble because it's not clear where we should go from here?
No, I think your intuition is exactly right. I agree with your first part, which is we just need to learn new processes. And I think that, again, I have the infinite belief in the human ingenuity and ability to solve problems. And this is definitely a rising problem. Like, we need to get on this. We need to figure this out, but we will. And the same thing that's happening with open source projects is happening inside of companies, right? Where certain companies are incentivizing people to write the most amount of code, and they're telling them you have to use agents for things. And the CEOs saying, like, I want to measure productivity of my people, and we need to use these tools, and blah 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 blah. And they may be well intended, but then what you get is you get a lot of bugs, you get a scope creep, you get lots of code that doesn't work very well, you get huge maintenance problems, and you get like toxic code bases that nobody wants to work with. And so I think that, again, different teams are better and better or worse managed. It's not consistent for everybody, but I do think that we as an industry need to figure this out, and I think we will. It's just a matter of these tools are moving really rapidly, and kind of as we build perhaps new processes, like you say, or maybe the models get slightly better or other things evolve, we'll definitely find a new stable point.
Yeah, I believe that too. And you mentioned licenses even before, and there have been instances, as you said, of, many different cases. Either some library gets rewritten with AI and with this different license from GPL to MIT, claiming there was a case where the maintainer claimed it was a clean room implementation, quote unquote, but actually because it was done by AI. So it's all, new territory. It's all nobody knows what they're doing basically with this. Do you think that we need to think about how licenses work, or do you have a vision about what's going to happen with this?
Yeah, I think that absolutely. Like, copyright needs to evolve 100%. Right? So copyright currently protects the kind of the form of the output, and I think that's going to be obsolete here. I think it is already obsolete, and so it'll take some time for the legal processes to figure this out, and I have no idea when that will be. It'll probably take way longer than it would be desirable for, and so I think that more of these examples will keep happening, and we can expect that.
Yeah, I think it's very hard to predict. Some are saying we maybe can copyright like the interfaces, and they use those as anchors. I mean, I don't know.
Yeah, but look, again, I'll just give you my take on it. And again, I'm one person. I'm very strange. I have my own ideas, right? I think that anybody who's trying to build a business and on like copyrighted headers or something is just not trying hard enough. It's really crazy, right? And so for my approach, I just look at this as just such an amazing time, right? We're building an amazing open community. We're open sourcing all this stuff because open source is like the better way to do software. And if you're still running a business where you're trying to keep things proprietary and that's your secret sauce, which there's a lot of companies, particularly hardware companies, that do that. Well, you're already 20 years out of date. Like, this isn't really a new thing. And so, you need to adapt and you need to figure this out. And they're going to be kind of having some challenges, but maybe it's just a forcing function to get them to up-level their approach in general. And that's also good for the world. So anyways, I'm generally the optimist, right? And so I look at things from a what can we do with it perspective, but that's the other way to think about it.
Also because we have basically covered all the doom and gloom, but there is also like the bullish case in which AI allows for an explosion of more open source software, and it makes it easier for people to pick up open source projects because now the ramp up to learn a new project is easier. There are a ton of positives that we can find if we look for them.
I'll tell you the positive I see, but let me just caution you on that, right? I agree with you. We're going to see a lot more software. That is definitely true. The problem I have with that, though, is that we don't want more software. We want more high-quality software. Having more left pads or other clones of other things is not actually going to make the world better. That is not actually what we want. We want high-quality, new ideas that move the world forward. That's actually value. And so for me, so building Mojo and building Max and building new communities and building new tools, AI is fantastic because what we're seeing is, so Mojo, because it's open source and because we have like hundreds of thousands of lines of GPU kernels and tons of example code, you can just say, hey, take this CUDA kernel, move to Mojo, and Claude will just do it. It will, and it's verifiable. It's a perfect use case for AI tools. And that's an amazing way to get started because now you get off of a proprietary ecosystem onto an open one really fast. Means you can do this without being the super expert. And one of the other amazing things is because of the way we built Mojo and because we have these higher level abstractions that cover a lot of the hardware details, it's really amazing because you can say, hey, I have this like legacy GPU kernel over here, move it to Mojo, and then adopt the best practices, and often it runs faster. And so that's actually fire. That's really cool. And the ability to create communities and catalyze new technologies faster than ever before is just like amazing. It's just such a powerful time in the industry.
Yeah, absolutely. And now I'm happy that we've given our own balanced take there with the bads and the goods about all of this. And I also wanted to ask you about AI and software specifically, because I saw that I think in November, you went to a podcast and said you used AI for coding and you were probably getting 10 to 20% faster, something like that. How is it going today, 3 to 4 months later?
Yeah, well, so it's a great question. So the tools have gotten way better since November. It's kind of a pretty significant step change, but it hasn't directly made my productivity any higher. And so it's probably 10 to 15%. It's way more reliable, and so it's way more pleasurable. And I think that don't underestimate programmer happiness as actually a good thing. And so productivity isn't the only measurement, but I don't think the aggregate has been that big of a difference. And so here's the thing that I think that a lot of people gloss over is that software production and creation is only a tiny part of that is about writing the code. Most of it is deciding what to build, working with other humans, working with a whole bunch of other issues. And so AI definitely takes the friction and the microaggressions out of large-scale refactoring, right? And things like this. It's fantastic for these automatable and verifiable tests, but you still have to make decisions. You still have to engage with things. And so what I found is I spend most of my time on the thorniest problems. And so this is actually the frustrating part, is that kind of the easy, it feels good part has been automated away, and you get left with some of the harder pieces. And so different lived experience from that perspective.
Yeah, I think you said something very interesting before. You said that tooling got better, AI makes you happier as a programmer, even on things that don't move, let's say, the bottom line of your productivity, right? What are these things that make you happier as a programmer, even if they don't count to the real productivity?
Oh yeah, so for me, updating test cases. So you make a change, and then you it's an intentional behavior change, and so you have to go update all the stuff. It's like, hey, just go do it for me. It makes me so happy to not have to do that, because I can start writing the PR summary or whatever and do this stuff while this is just being done for me. I don't have to worry about the mechanical piece. Doing the rename X to Y, right? But do it contextually sensitively, and you have to move an argument around, or just like very mechanical stuff going away. It's just wonderful. And so there's a lot of things like this. Also, the tools are so great with in-context learning. They can even handle obscure things like MLIR syntax and stuff like this. And so it's just amazing to me. Just you have the magic moments where even tab is still very valuable and still quite powerful. And so there's a lot of different aspects of that. But again, you still have to, I haven't seen it where it's like, okay, well, here's a generalized idea of which direction I want you to go, and it can actually do that. I don't see that working.
Yeah, but I think you mentioned very valuable things, and it stays within a pattern that I've seen also with many teams that are using AI successfully, and they all mention, rather than, I don't know, some big moonshot that they're able to do with AI, it's more about enforcing better the basics and the basic hygiene, like testing docs and basic code health and code quality, all things that now you can enforce in an easier way than before, because AI can actually take care of a lot of that.
Yeah, so I'll give you the caveat here, right? So again, I'm a pretty experienced programmer, right? And so lifting me 10% is actually a big deal, right? And stuff like this. And so what I've seen is that people that are earlier in their journey and they're still learning things get way more than 10%, right? And so I'm definitely an outlier in that way. But I'll tell you an example of something that I want to see. This is something I would love even Modular to do. We haven't had time to build this yet. Is say, hey, AI, I'm going to have a readme.md in every directory of our technology that we're building. And I want an architecture doc in the repo that describes how that each module works and what it does and what the responsibilities are, et cetera, et cetera, et cetera. Just good, really, really amazing design doc. And say, well, first of all, you need a little bit of co-design with the AI to make sure that the architecture doc is right and then it's structured the right way. And you need review of what's going on. But AI can generate 80% of that almost one shot, right? And so you can iterate on that, you can get that in, and then you do upfront work to build out this architecture doc. But then I want a weekly cron job that says, go scan all these docs and identify likely out-of-date things.
Yeah.
And I think that then what you could do you have to do both. You can't just do one, you have to do both. But once you do that, you could have really amazing design docs that make it way easier for people to onboard into the project, make it so that the AIs themselves can understand the design that's desired, not just what exists, right? And I think that in the process of creating these architecture docs, you get a lot of these like, okay, well, that is how it works, but it shouldn't work that way. And it could actually drive some of the architecture forward. And I think that an approach like that would be very powerful, both for projects like ours internally, but also for open source projects as well. Because again, what you want is you want people to get into the project, be able to understand things and learn and upskill very quickly. And I think this is one amazing opportunity that I haven't seen people tackle yet.
Yeah, it's a fantastic use case. I agree. And it also, saves your precious time and brain for the things that actually deserve it, as opposed to updating the docs or this other test. And
well, and this is something where we do actually have internal docs, but they get out of date. And so what's worse, not having docs or having docs that are out of date?
Yeah. It's almost worse to have them out of date, if you ask me. Almost worse. I don't know.
That's right.
Yeah. You also said something interesting before when you said you're a very experienced programmer. So for you, even getting 15% better, it's something. And while if you look at younger folks, they might get way more than that out of AI, right?
Absolutely.
So has the latest models and tooling with AI is shifting what kind of qualities you're looking for in engineers that you're hiring, and or even how like junior engineers are working, and are you being intentional about this in a way?
100%. So again, I'll give you, I have these weird ideas about the world where most people are running around saying, yeah, we're not hiring junior programmers or we're laying off all of our people. We are actively hiring. So we have way more interesting problems to solve than we have amazing people to do it. And we do have a lot of amazing people. But we're also hiring new college grads and other people that are junior. And interns. It's amazing because a lot of these folks bring a completely different expertise. Like they're AI tool native. Some of the more experienced people, they're using the tools, but they're not using them the best way. The tools change very rapidly. And so like this willingness to adapt new technologies and things is very powerful. But also, again, what I think is true for all teams, and again, I like to build things including teams, is that you want people at all levels within a team. If you have all super experienced engineers and no juniors, or you have all juniors and no experienced people, you get into problems on either side of this. Good teams have people at multiple different levels, and they're learning from each other, they're working well, they can be effective, they can be taking on different kinds of problems and things like this. And so what I think that agents and new coding tools have really shifted is it means that new college grads, or the power IC that is very proud of never being a manager, well, everybody is now a manager. You have to think about things with manager thinking. Even if you're super proud of never being a manager or something, well, you have to bring and learn the thinking. Even if you're fresh out of school, and again, I think some of these folks learn way faster than others, you have to bring that thinking, because it's not just about the outcome, but it's about, what am I trying to achieve? What's the best way to do it? What's it going to be like to maintain this over time, right? These second order questions end up mattering way more than how quickly can I pound out the code, right?
Yeah, absolutely. And I think, it feels natural to think that junior engineers might be in trouble because they are exposed to a lot of these things from the get-go that we're not exposed to before, like, high level thinking, code reviews. But I have this feeling, this is part of my own weird ideas, that we are making this judgment based on kind of our outdated intuition about what engineers need to be able to do versus what they are not needed to do. While instead, when the tools evolve, people learn based on the tooling they have at disposal. So it's like, a liquid that fills the container, the shape of the container they're in. So I think the junior engineers are just will grow as fast as they've always grown in ways we probably don't expect or can't predict. But they were probably, as you said, they're an AI native. They're probably going to be more effective than many other more seasoned engineers who may have trouble adapting after many, many years of doing things in a way.
Well, the way I look at it is the AI amplifies things, right? Yeah. And so it amplifies your ability to write code, it amplifies your ability to learn, it amplifies good or bad architecture. Like if you scale it rapidly with AI, you can get a mess if it's already a mess. But within teams, I think that what's going to happen is that the people, as you say, that refuse to use new tools or refuse to evolve, those just kind of get left behind.
Yeah.
Right. Mm-hmm. And the people that lean into this, the people that are still motivated and hungry and curious and want to learn and grow, they'll grow way faster. And so, again, everybody can choose to do what they want to do. I think that I've seen lots of people say AI is ridiculous and none of this stuff is working and it's all BS. And that's not true. I've also seen people say like, oh my God, like coders are out of a job. Like all AI will just be generated or all code will just be generated. It's like, well, I don't believe that either. Right. So, but you do have to lean in and have to figure it out.
Yeah, and I think you got a great analogy before. You said basically all engineers are managers now, and AI rewards manager behavior. But I mean, my provocative take is also that engineers notoriously, most of them, they don't want to become managers, right? I mean, they like the
growth mindset is required.
Yeah. So are you finding like easy for your people on your team, this kind of transition psychologically in terms of skills they need to apply? How is it?
Yeah, well, so I can't give you an answer to that because we have a large team. And so different people are adapting at different speeds. And so some people are struggling more than others. And I don't think there's a good indicator. I don't think that Modular is unique in that way. I think that we probably have a representative slice of many very high-tech teams. So I don't think that we're unique or outlier, nor do I think we have a magic solution. What I do think is important is I do think that it's important to encourage some of the people that are leaning in, even if they feel crazy and their token budgets are expensive, and enable them to pathfind and figure out, okay, well, what actually works in practice? And what I always challenge people to do is say, look, vibe coding out some amazing demo and like having some crazy thing that's really exciting and very cool is actually not success.
Yeah.
What is success is when code gets in the product and ships.
Yeah.
And so there's sometimes a gap there. And I've seen some danger cases where, somebody got very excited and some person who maybe isn't even a professional software engineer is like, oh, wow, look what I did. It's like 80% of a cool thing. And it's like, okay, that is really cool, but that's not actually a success for us building production software. Like it needs to be developed the right way, good incremental development, land with test cases. Like you have to actually do the whole thing, and landing and integrating and all that kind of work is also super, super important. And without it, you don't ship. Or if you ship, you have a product that you can't support. And those are some dangers.
Yeah. Do you think, before you mentioned that we probably need to figure out better models for open source projects, for example, for PRs and for development process of that kind of software, do you think we need to figure out something similar in a way that changes how we've been thinking about the software development lifecycle and all the various steps, or it's just that AI is accelerating every single of these steps, but the pipeline stays the same anyway?
I think that it's the same. The same systems are useful. There could well be big breakthroughs in that. I'm not exactly sure what they are. I can't see anything obvious. But what I see is that AI is an amplifier. It allows you to move faster. And anytime you take a task and you compress it, it puts pressure on all the others.
Yeah.
So if you have really slow CI, well, guess what? That's going to be a big problem. So you need fast CI. If you don't have test cases, that's going to be a big problem. And so, but fast CI, test cases, like these are all actually best practice anyways.
Yes.
And so again, what AI is doing is just forcing a conversation. And maybe it's gigantic amounts of tech debt the teams have accumulated that have never been a problem, but now that tech debt ends up really holding them back. well, maybe it's time to invest, and maybe that's what it forces. And I think that's actually probably pretty good for the health of various projects.
So basically we're saying that best practices today have even a higher return on investment that they ever had because of AI.
Yep. Well, and AI is an amplifier, and so if you have a mess, you'll get bigger mess fast. So.
Yes, I don't think that's what anyone wants to do, but I think it's what many teams are doing, actually.
Well, and also I think that many management teams or non-technical CEOs or things like this, they're really encouraging that because they don't understand what's really happening. And so this is something where it's actually very challenging because I talk to lots of really smart people, and many of them are seeing this firsthand because they're the engineering mindset, and yet they're getting pressured like, you need to go faster, you need to do this, you need to do whatever. And the people that are putting that pressure, they're well-meaning, of course, right? They want people to be productive and they want their products to move fast, but they don't fundamentally understand the thing that's holding them back. And if you don't make those investments and you're just saying go faster and I'm going to measure you based on the lines of code you create, right? You're going to get a bad outcome. So
I think it's complicated because, as you say, of course there are very bad CEO stories and so on, but there are also people who are, as you said, well-meaning because they are meeting resistance from engineers, as we said before. So I think it's tricky to strike the right balance where you want to be intentional and try to drive something top down and support, right? Not just leave it bottom up, without being like imposing and constrictive.
On balance, I think that it's good to encourage people. Like if you push the issue, if you encourage people to adopt new tools, if you do it with a balanced set of expectations, I think you get the right outcome, right? Because you don't want to be left behind. Like you don't want to not fix your CI or something, right? But but you have to have reasonable expectations, and I think this is where the whole world's calibrating. And there's a lot of experiments being run. Different people are taking different takes. Maybe my take isn't aggressive enough. I don't know. And we'll see what happens in a year or two, right? And what matters is, again, do these companies ship more good products? Like, does it make their customers happier? Does it actually work? Do they have service outages? Like, there's like these things that are measurable outcomes. And so it's a little bit too early to tell in many ways.
How is it at Modular? I'm curious, do you have like shared artifacts like CloudMD files with the team, or you have ceremonies to where people talk about practices to share knowledge? How it is on the ground?
Yeah, so Modular is really different than most companies for a bunch of different reasons. So first of all, we do follow best practices. I believe in software engineering, we have a monorepo, we have fast CI. That seems like an obvious thing, but for a company working on AI infrastructure, that's almost novel as far as I'm aware. Like TensorFlow CI used to take days to run, for example, because you're testing all these exotic GPU things, et cetera, and they're all end-to-end tests, and it's just a gigantic mess. And so Modular is very different from that perspective. The other major difference is that we have open source, and we're going to open source a heck of a lot more of our code. And so Modular,
higher
about
standards.
6 months ago, will look very much like an open source project from our software perspective, which is extremely different than most companies. And I think it's the modern way to run a company, but it's something that I think is very different. And so as a consequence of that, first of all, yes, we have shared Claude skill files and things like this, and we're publishing them already in our community. We're using them internally. And so it's, again, this is part of the tooling. It's like Git from 10 or 20 years ago, right? You need to figure out how to use the tools, and you need to work with them as they evolve. And so, you need to invest in this kind of stuff. But we have certain advantages because, first of all, the architecture side of building our software development ecosystem and our software development lifecycle practices and things like this were built for scale and built with the best knowledge of all the open source projects and how to keep high velocity software engineering. But then also, as we continue to open code, right, it really pushes us to like invest in building scalable communities. And that's actually what you want, is you want to be able to scale with a number of contributors and number of people working with your technology. And that's something I think that most software teams have never even considered, right? Most people are just trying to get the last bug fix out, right? And it's just a very different way of looking at things.
Yeah, I think it's one of the benefits of running successful big open source projects. It raises your standards and keeps you more accountable, right?
That's right.
Yeah. And
here's one of the bigger problems I have as a leader at Modular. So, which is very different than I think many companies. On average, most modular and software engineers are so principled, and they like push back so hard on tech debt. They're like, no, we have to do it the right way, which is a core part of our culture, right?
Yeah.
And we're building things that will last 10, 15, 20 years. Like, so you have to build it the right way. But you also have to be balanced, and you have to think about this. And so in many companies I've looked at, most people won't even have a conversation. They'll just, the engineer will just do whatever to get the bug out of their queue and just hack something, and nobody cares. Yeah. And so we have so many people that want to build things the right way and invest in building and being proud of what they're doing. That sometimes it's like, okay, well, actually, tech debt can be a good thing.
Yeah.
It's so funny. Tech debt is only bad if it doesn't get paid down, but it can be the right way to unblock progress. And it's a very funny dynamic I haven't seen before.
Do you find this tension yourself? I mean, as a principled engineer who has created a lot of fantastic software, now you're also a founder, a CEO, so you need to take care of time to market and investors and absolutely. Funding rounds. So is that in your head as well?
Well, I want us to be productive, right? But also our entire approach with Modular has been to win for the long term. And so internally we talk about winning big in the future is more important than just winning tomorrow, right? And so the long-term thinking is very important for building the kinds of architectures and the technology and making the investment that we're doing. And so for me as a founder and as a CEO, that means that I look for investors who are aligned with that approach, aligned with that vision, that understand the stakes. We're building a platform for heterogeneous compute. We're building effectively, it'll take a little time, but it will feel like a hypervisor for compute. This will give people choice. This allows people to scale across lots of different chips. This allows hardware makers to be able to innovate and get their chips adopted and used by software enterprises. The stakes are extremely high. Like we're the only ones even remotely trying to solve this problem. We're not just a layer on top of PyTorch like roughly everybody else is. We're making fundamental investments, and by the way, it works, which is one of the things that makes it it's a very big bet, and it's a very big investment. Our team's almost 200 people at this point, but it's really aligned with what compute is doing, what the world needs, and it's very much a complement to people that are just buying and installing GPUs and reselling them. And so this is one of the things that makes Modular so fun, is that we're able to make the deep tech, high-tech investments. We're able to make a ton of open source code. We're able to invest in communities and build new programming languages, all the fun, shiny objects. We have an amazing cloud platform. And so like if you're into cloud, Modular is an amazing place because we're not only building the Kubernetes and SaaS wrapper on some open source thing, we're building that entire stack and vertically integrating the whole thing together. And so being able to work in that kind of environment is really pretty unusual, and particularly for startups. And so for me, it's my generalized approach to solving and cracking large-scale problems. This is why I've been able to do certain things over the years, but I think it's very unusual, and a lot of people haven't seen that before.
Yeah, but that's a fantastic vision and mission, and I think also a fantastic closing note for this chat. Thank you so much, Chris, for coming on the show and for this amazing chat.
Yeah, well, thank you for having me, Luca. And if anybody out there is interested in Modular, we have a really cool webpage, of course, and we have a lot of open positions. And so please check out our careers page.
We link everything in the show notes. So thank you again.
Awesome.
Thank you so much for listening. If you found this chat valuable, you can subscribe to the show on YouTube, Apple Podcasts, Spotify, or your favorite podcast app. Also, please consider giving us a rating or leaving a review, as that really helps other listeners find the show. You can find all past episodes and learn more about the show at refactoring.fm. See you in the next episode.